fellow scientist and mathematician. Welcome to my YouTube channel, which focuses on mathematics and science. Welcome, and let us learn together, whereby mathematics is simplified together with the physics from the fundamentals, so that every person can learn and understand the rules step by step. My channel name is Luke Aaron 1. Welcome, and let us learn together. Hi, my fellow mathematician, wherever you are, welcome to our study. We want to look at the derivative of exponential function. We want to see how we obtain the derivative of exponential function from the definition of derivative. So f of x, f of x prime, that is it is d of function f of x with respect to x. So this is the definition of the derivative. Limit as h tends to 0 of function x plus h minus f of x, everything into bracket, divided by h. So our function, we let our exponential function to be exponential x. So the derivative of this function will be given by limit as h tends to 0 exponential. So this function here, we add it, your function you add h, so you have exponential x plus h minus the function which is exponential x over h. Then using the property of index, or the property of algebra, this part here, it can be separated. Exponential power x plus h is the same as exponential power x multiplied by exponential power h minus exponential power h over h. Now, as the limit tends to 0, exponential power x does not depend on h. So we can factor exponential here to be left with the exponential power h minus 1. And now, since exponential power x does not depend on h, as h tends to 0, it can be factored out. That's why I factored it out here. Exponential power x into bracket limit as h tends to 0 of e exponential power h minus 1 divided by h. Then we are going to use the L'Hospital's rule. L'Hospital's rule, because now when you substitute this function with 0, it will be undefined. But you can make use of L'Hospital's rule, whereby now we are going to differentiate the denominator and the numerator with respect to h. So exponential differentiated will remain exponential h. One differentiated is 0. H differentiated with respect to h will give us 1. Then now we can substitute. Limit as h tends to 0. Where you have h, you substitute it with the 0. So when you substitute x with the 0 to exponential power h, you are going to get exponential 0 multiplied by limit by exponential x. So exponential power 0 is 1. So you have exponential power x multiplied by 1, which is equal to 1. Hence, the derivative of exponential x is the same, is exponential power x. In general, if our exponential is a power x, where a is a real constant, then how do you obtain the derivative? So to get that in derivative, we are going to use this fact that exponential power natural logarithm of a power x is a power x. In the other ones, exponential, when we take exponential power natural logarithm of any number, it is that number. Also, logarithm of a number power index, that index can be put in front of the logarithm using the laws of logarithm. So that is what we are using here. That is what we are applying in our case. So natural logarithm of x can be written as x multiplied by natural logarithm of x. And the exponential, a power x can be written as exponential natural logarithm of a power x. Now here a is a real constant value. So you want to get the derivative of d of a power x. A is a constant positive natural number. Now this one, we have used this rule here. It can be written as, instead of a power x, we can write it as exponential x natural logarithm of a. Now to differentiate that, we are going to differentiate the exponent, that is x natural logarithm of a, and we keep this exponential power x natural logarithm of a constant. So that is why I've written it this one here. So when we differentiate this with respect to x differentiated will give us 1 times natural logarithm of a here. So you have 1, there is 1 here, 1, x differentiated is 1 multiplied by natural logarithm of a, natural logarithm of a multiplied by exponential x natural logarithm of a. So this one is the same as a power x. So you can write it as a power x natural logarithm of a. So that means that derivative of any exponential function a power x with respect to x, the answer is a power x natural logarithm of a, whereby a is a constant. So that is the derivative of exponential function generalized. But the specific case, it is only when you have a exponential power x, which is the result is the derivative is exponential power x. But if now you have a general case here of exponentiation, a power x, whereby a is in a natural number, when you differentiate it, you are going to get a power x multiplied by natural logarithm of a. Next, we want to look at a differentiation of logarithmic function. So we want to prove that when we are given y is equal to logarithm of x to base a, then when we differentiate, the result is 1 over x natural logarithm of a. So to do that, we use the laws of logarithm. One of the laws of logarithm tells us that logarithm x to base a is the same as logarithm of x to another base divided by logarithm of a. So when you have logarithm of a number, you can write them in terms of logarithm by writing them to the same base. So it will be natural logarithm of x divided by natural logarithm of a. So we are going to differentiate this. So natural logarithm of x divided by natural logarithm of a is a constant, so we can take it outside the derivative, because it is natural logarithm of a is constant. It is not affected by the derivative, so we can take it outside the derivative function. So natural logarithm, derivative of natural logarithm of x will give us 1 over x times natural logarithm of a. Hence, the derivative of log of x to base a, the answer is 1 over x divided by natural logarithm of a. We have a simple example here to prove that y differentiated is equal to 1 over x when you are given y is equal to natural logarithm of x. So to do that, you multiply this both sides by exponential. You introduce exponential both the left hand side and the right hand side. So exponential y is equal to exponential natural logarithm is x. Then you differentiate this function implicitly. So you are going to get the exponential power y dy over dx is equal to 1. X differentiated is 1. Then you divide both sides by exponential power y to be left with dy dx. Now exponential power y is equal to x. So 1 over x is equal to that, meaning that when you differentiate natural logarithm of x with respect to dx, the answer is equal to 1 over x. So in our study, we have found out that when you are given a function, exponential x, its derivative is exponential x. When you are given exponential ax, where a is a constant value, its derivative, we have obtained it as a power x natural logarithm of a. And when you have logarithm x base a is a constant, a real constant number. Its derivative is 1 divided by x natural logarithm of a. That is what we have obtained today in our study. so much for watching this study. Kindly like, subscribe so that you won't miss any single video which I upload now and then. Also, you can make a comment there. You can suggest any area of study which you would want me to address, and I will be more than willing to tackle it on your behalf. Thanks so much for your support, guys.